few of the concepts we've spoken about previously. Hopefully everybody can see my screen here.
Yeah.
Yep, perfect. So you'll see here from the URL, this is one of the published quick starts. So you can actually access all of this content and walk through this on your own. I'm actually sharing right from the public site here. So it's a really simple flow. Essentially, what we're going to do is we're going to work with a bunch of FHIR messages. Now, these happen to be sitting locally on my laptop. Give me 1 second to pull this up and I can show you what that data actually looks like. Okay, so this is inside a designated demo folder on my laptop here. In this case, I have one file per member. And this is the actual content of the file. So it's in JSON format. You can see all the data we want is there, you know, MRNs and SSNs and name, conditions. So there's member information. There's also significant amount of medical information in there as well. But the challenge is, great, if this is the format that we as an industry are agreeing to use to store and transmit patient medical information, how do we actually work with that inside systems that want to run SQL queries? Historically, whenever we had this, we'd have to do a whole bunch of data engineering transformation, go find an ETL tool. So I'm going to walk through the process in Snowflake of how we can actually ingest that data natively as it exists, and then build structured data products on top of that. So really simple here. Yeah, I'm sure just about everybody on the call has probably seen the Snowsite UI before. This is just one of our UIs for interacting with Snowflake. I've just got a bunch of very simple DDL statements here to create a database, schema, permissions, roles, etc., a couple warehouses for this particular demo. The database here is called HL7 FHIR. You can see over here on my resource tree, it does not exist. So we're starting from 0. Go ahead and run these statements. The other interesting one as well, you'll see when we're creating warehouses here, a few things we touched on in the last call or maybe the call before, establishing the default size, the default state, the starting state. So I could actually create a warehouse, but have it start off in a suspended state. I can define how quickly that will suspend if it sits idle. I can define that cluster. So, you know, in this case, I've said min and max is a single node, but if I wanted to allow this to scale up, I could change that and say, hey, this is going to go between 1 and 4 nodes. For the sake of this, let's just leave it as a single one. And then a bunch of very simple, straightforward here, just roles and permissions. Now, what I'm going to do is I'm actually going to take these JSON files that are sitting locally on my laptop. I'm going to copy those up to an external stage to make them available for ingestion into Snowflake. I'm actually going to do that using SnowSQL, which is the command line tool here. And I have deleted accidentally last time I ran this demo. I deleted the command that I wanted. So hopefully that's still in my history. It is. So we're going to connect to SnowSQL. You're all welcome to steal my password if you like. Not really, but there's nothing important inside this demo account. So very simply here, we're just going to specify which database. Oops. Nothing super exciting happening here, and use warehouse. Now this single command, you can see quite literally from the syntax, it's copying from my local machine. It's going to copy. I've got about 600 of those JSON files, so enough that it's not a trivial process. But when I run that, so it's actually now copying those individual JSON files up to that stage, which in this case is an AWS stage. I have about, it's about 550 files, and I believe each of these are a couple megs. So this will take about 60 seconds or so to copy up. But just as a quick recap, so this is the stage that we're working with right here. We're actually copying that data into the stage. So from my local laptop. Now, the fact that I'm doing this batch mode is not important. This could be coming in through a stream. This could be, batch oriented, stream oriented, user-driven or process-driven, really makes no difference, because we'll see that once that copy operation completes, take just a couple more seconds for that. So what we're going to do is the first thing we're going to do is we're going to create an empty table, and the table is going to be what houses that raw data. Now, there are a couple of references a few minutes ago to using blob columns in tables. The variant is a Snowflake specific data type that allows us to store JSON data in its native format, but then we can start doing some really cool things with it. Now, the benefit of storing that data in its raw format, there's at least two significant benefits. The first one is that, hey, it alleviates me from having to go find an ETL tool, and or someone who knows how to use it, and then define the mapping of, hey, what do I want to pull out of these JSON files and what structure do I want to map them into? There's then overhead in terms of building and maintaining that process, running that process every time I want to get the data. It also introduces questions around data quality, data completeness, correctness. Did I accidentally mismap some of these columns, from the JSON into the target table? So in this case, we're actually just going to ingest that data as it exists. So I'm going to create this table. And this is a single column table. The column name is called JSON string. It's a variant type. Now, in order to be able to use that, we're going to create a file format, and this is a standard Snowflake operation. We create this for working with CSV files or JSON files or XLS files. This is a one-time operation. And then once I've defined that file format, what I'm going to do is I'm going to copy the data from the stage into the table. So it's going to go through all 600 files. It's going to use this format we just identified, and if for any reason it hits an error on one of those, it'll just skip it and move on to the next file. Did I not specify warehouse? I don't think I did, so let me do that manually. I'm going to use this guy. Now let's try that command again. So those files being copied from that stage into the table. And now if I preview that table, we can see 557 rows. So it looks like it copied all of the files successfully. If I now preview the content of that table, not surprisingly, it's a table with a single column called JSON string. And inside each row of that table is a giant block of JSON. Now that's great. That is in fact the exact same data. If I were to look up, that UID and go find the corresponding file, I'd be able to compare this to the JSON in the data file sitting locally on my laptop. But what can I do with this inside a relational platform? The answer historically has been not a heck of a lot, right? You can't really write SQL against JSON, except in Snowflake you can. Now, I'm not going to physically reshape this data. I want to keep all of that raw data there. If someone comes back and says, hey, I just looked at a record and it looks like the data might be wrong or something's missing, I can now come back to this table and say, this is the complete record as we received it. I didn't do a single thing. I didn't make any changes. I just ingested it and stored it in its source format. But for convenience, what I'm now going to do is define a view. I'm actually going to build two just to separate things out a little bit. So I'm going to create a patient's view. And then what I'm going to do is I'm going to specify using JavaScript dot notation here. I'm going to specify where each of the fields I'm interested in can be found within that JSON. Okay, so I'm going to define a view that includes, it's about 15 or 20 columns here. And these are just the patient's elements that I'm extracting from that JSON. Now, this is a view. There's no physical copy of that data. The only data that exists is still in JSON format in that original table. I'm going to do the same thing here with conditions. Run that. So I now have two separate views, and I only have one physical copy of the data as it existed in the original message. If I now preview the view, we already looked at what the table looks like. It has all the data, but it's not in a very useful format. If I now preview the view, I have what looks and feels like a standard relational table. Right, so this is typically, in an ideal world, this is what we would have produced as the output of an upstream ETL process, and then we would have ingested this as a CSV file or a Parquet file or some other format. We would have then ingested this into Snowflake. In this case, I can just cut out that whole data transformation step altogether. So it's a much simpler ingestion process. And I also don't have to worry about, did I drop or delete or misconfigure something during that process? I can now see all of the data, either in the source format or in this nice, clean, structured format. Now, a couple of the things I'll show just really quickly here. We see that there's some information here that's probably sensitive, PII, HIPAA information. So we're going to really quickly create a couple of filters here. First one is going to be to mask PII data. And as I create this, we can see very quickly, we're creating a policy that says this policy is going to filter based on active role. So if the person running the query is a sysadmin, then return the value they're asking for. Otherwise, if it's any other role other than sysadmin, we're going to return this static string. Now, this is just a policy. That's the first step. We create the policy, and then we tell Snowflake which columns to apply it to. So I'll create one for PII. I'm going to create another one for HIPAA information. So I now have two policies, and then I'm going to assign them. In this case, we can see I'm going to assign in the patient view, 3 columns here are going to be assigned a combination of those two filters I just created. Okay, and now this applies moving forward. So any new records that get inserted into this table inherit the same masking policy. And then let's test that out. Let's see how it goes. So if I use the sysadmin role and I run a query against that patient view, just looking at the first 20 rows, you recall the policy said, if you're a sysadmin, you can see everything. So not surprisingly, I see all of the columns I asked for. If I run the exact same query, it is the query if I format it the same. If I run the exact same query, but as account admin, which actually has a higher permission level by default than sysadmin, but if I run this as a non-sysadmin account, we'll see what happens here. And all of a sudden, those columns to which I had applied the masking policy are now masked. Okay, and keep in mind, all of these are virtual filters, masks, views. These are all applied at a cascading level. So I defined the masking policy against the view, but in reality, the data itself only exists in bucket or in object store as that raw JSON data. So for the users that want to see a relational table, I can simply expose these views and say to them, great, go ahead, start building your dashboards, your reports, your analytics, your other downstream data products. And if someone wants to come back and say, hey, there's something missing, something that was in that original FHIR message that I don't see in the view, I have all of that data available to me in the original base table, which was this guy up here.
So is this a kind of specific storage technology made for FHIR, or is this essentially just putting everything in a column and then creating a view on top of it?
Yeah, you can do this with any JSON. There's nothing specific. The only thing in this entire demo flow that is unique or specific to FHIR is the actual the element names and the values that correspond to it in this file. I mean, if this was a manufacturing product definition that was in JSON format, I could do the exact same thing there, but I would be using different values here.
So the FHIR format, it would dictate that all these names are going to be the same across clients, and then we can pretty much name them the same we want.
Correct.
Got it. This is nice.
Yeah.
Yeah,
So that's
and
an industry standard format that hey, that a given value, an MRN, is always going to come in a field called, let's see if I can find it right off the top of my head here. Anyway, there will be specific names where you'll be able to say, this is the path in the JSON file to find the MRN or a patient ID. But yeah, functionality wise, yeah, it's obviously a very simple process, but if you think about how you would historically have implemented something like this of, hey, I've got data coming in that FHIR format, either in batch mode or through a stream. How do I get that into a dashboard or an analytic product? And, really incredibly simple in Snowflake. It's just a matter of setting up that view and then having a process read, either listen to that stream as the data is being streamed in and drop it into that table. Once it's in the table, it automatically propagates through the view and any other downstream products you built. So very, very simple in terms of its implementation, but quite powerful in terms of how much simpler that process is than historically all the additional steps you would have had to follow to make that data queryable and interactive.
So that definitely looks like a lot more palatable of a process. But a couple questions there. One is like, are there? I mean, if the data ends up effectively all being stored in a single JSON object, are there performance implications of that versus like the harder way of actually splitting it up? If you're only looking for a few specific elements, are you churning through the whole JSON object in order to get those based on the view, or is it?
Yeah, so yeah, it's a great question. I think I don't have my list up. Was that Sam? It's a great question, and the answer is at some point in terms of scale and magnitude, you might start to see a little bit of overhead being incurred from parsing through that JSON, because it is in fact doing that, right? If I write a query that says select star from the view, it's going to go back and say, well, that view defines 20 columns, and those 20 columns are actually pulled from these 20 elements in the JSON, and then go read those elements. So it will parse through the JSON to fetch that data. Now, still has access to a lot of the same query optimization techniques that you would have if you were storing that data physically in object store in a traditional Snowflake table, but it is still doing a little bit of additional processing. And if that becomes a performance implementation or has a performance impact, keep in mind, you always have the option of simply materializing the view. Right. In that case, you could say once a day, materialize the view. Like it's a completely trivial process once you've defined the view. It's just a performance switch that you're flipping.
That makes sense. And then for these views, since this is industry standard stuff, are these definitions available somewhere?
Yeah, these are all HL7. So you go to the hl7.org web page. It will give you the full spec on the FHIR standard.
I meant the view definition for Snowflake.
This view is arbitrary. I just pulled out a couple of fields that would be, intuitive and easy to interpret for someone who doesn't have any familiarity with,
right.
MRNs or some of the more obscure value or element names in there. So this actual view is not a component of the standard. The standard simply specifies what all of the values that exist within that particular message would be. And then I've just arbitrarily pulled out 20 columns here, 25 columns that looked interesting. So
yeah, and that makes sense. And if it's a view, that's trivial to change, so it doesn't.
Totally,
don't have to do everything in the entire data set all at once if you don't need to. But okay.
Yeah, and that's it. I mean, if there were a scenario where you actually needed all of those values, all of those elements in a structured format, sure. You would have to define this view once, but then once you've got it, you can use that against any other FHIR format message, and it's functional. Like that unless the standard changes, all of these JSON element name references will remain valid. Cool. So yeah, it's a really quick to the point demo, but hopefully that illustrates how easily we can take something that intuitively doesn't feel very SQL friendly, analytic friendly, and with a matter of 20 lines of code in Snowflake, it's probably 120 lines of code, but with a very small snippet of code, I've now got this into a format that with essentially zero overhead and pre-processing, as soon as that data is available on the provisioning side, it can be queried and analyzed, and downstream users can build things on top of that using SQL, or if they prefer, through Snowpark. Hey, write Python. You want to build and train an ML model? Like, great, go ahead, do that. This is just your source data, training data, test data, whatever. Cool.
And then probably not the most robust kind of visualization, but then you can do some snow side on top of it. Hey, Chris. Just to
Yeah,
get
I mean,
some
it's a
visualization.
view, whatever you want to do with that. If it's visual dashboards, you use Power BI or Click or whatever your preferred BI tool is, great, go for it. If you want to build other Snowflake native data products and join that with other data sets from the marketplace or internal first party data sets, like it's a SQL view. You do with it anything that you do with any other table or view as well. So
It sounds like that was very helpful. Samkin, and hopefully that
Yeah.
resonated.
Indeed, I was cheering in the background when on mute. Also fist pumping at the same time.
Yeah. I would have loved this if I have this particular tool back in when I was in my previous work. Yeah.
Likewise, me too.
Oh yes.
Oh
Yes.
my.
I've spent many hours trying to parse out JSON files and figure out how to map them into relational structures. So
only the HL7 thing, it was kind of what the heck is demon? We had to do exercise, something like that. Because every time that they were talking about the CQL and these kind of things, oh my, it was a nightmare. Or at least we have this now. Yeah.
Yeah, and this is why for things like the Know Your Patients report, I'm really trying to push to be like, hey, when can we use the FHIR data source? Like that seems potentially.
It'll make everything so much easier.
Yeah.
Yeah, it also really helps when you get into like cross organization or potentially cross departmental data interaction, data sharing. I don't think we've talked much about the Snowflake marketplace, but actually conveniently have a tab up here for that. I know we've only got 2 or 3 minutes left here, so I won't be able to demo this for you or anything, but this is available to all Snowflake customers. You can be either a consumer and or a provider or a publisher within the Snowflake marketplace. And essentially think of this as basically a giant catalog of pointers to data sets that have been published by trusted organizations. So if I'm interested in, for example, COVID data sets, I just type in a keyword and I have 62 different data sets published by a variety of different organizations, some of these public, some of these private, various different access restrictions in place. Lots of them are free, can be accessed, with a matter of a couple of clicks. But the really cool thing is when I see one that's of interest, and lots of different domains, right? If I'm interested in weather data, 3 different providers, another 60 different data sets here that are available.
That IQVIA that you have before.
I was just gonna say that, Carlos. That's probably your old HL7 work.
Yeah. No, the IQVIA. It was
IQVIA, yep.
Yeah.
Was that
So
the COVID?
IQVIA, yeah.
That's where Carlos used to work.
Yeah. Oh yeah, there is. But it was an data as a service. Oh, okay.
Yep.
I'm gonna dip into that to see what they are putting there.
So everything is available, but it's by request. So they would essentially just do a data share. It's a bit misleading. It's saying that it's delivered through the marketplace. All we're actually doing is facilitating the conversation where IQVIA would set up that direct data share to the customers that have a contract in place with that particular data set.
Okay. Yeah.
Yeah, just as an illustration though, if I do see one that's free, that means it's available, can be used right away. If I click on that and click, yes, I want that, let me get a copy. I can give it a specific name. I'll just accept the default. So COVID-19 Data Atlas. Go ahead and click on get. Just take a couple seconds. And you can see in a matter of a few seconds, if I now go back to my resource tree.
There it is at the beginning.
Yeah, there it is right there, COVID-19 Data Atlas. And you can see that I have access to all of the contents of that share I can start querying it. I can analyze the data. I can join data from that connection that I just created to that COVID-19 data set to my own internal data sets. So super easy way of enriching my own internal first-party data with those external publicly shared data sets. And you saw how quickly this popped up. There's nothing happening in the back end in terms of replication. I very intentionally said that the marketplace is providing pointers to data sets. That data set itself continues to be hosted by the organization that published it. So we're not creating separate copies every time someone connects to it, right? That sort of violates Snowflake's core tenet of stop replicating data. So there is only one copy of this data sitting in the cloud, right? In this case, it's AWS. So there's one copy of this COVID-19 data atlas, and this could be potentially being accessed by dozens or hundreds of different organizations through the marketplace. They're all accessing that one physical copy. So I can start building products on top of this without ever having to worry about physically storing this data, right? It's stored for and the storage is paid for by the publishing organization. The only thing that I incur in the way of overhead or cost is just whatever compute resources, whatever warehouse I use to run queries and define those joins. But really powerful how, historically I'd have to go find that organization, have the conversation, set up the agreement to consume that data, and then figure out how do I actually get it? Are they going to set up an FTP server? Are they going to send me a thumb drive in the mail? Like, how are we going to actually physically transfer that information? The whole ETL pipeline is gone. Like with 2 clicks, I now have this. It's a local data set inside my Snowflake environment, or looks and feels like a local data set. That's maybe a better description. So.
And probably a consideration for if FHIR is sending or has to do any extracts that you then send over to any partners or in your ecosystem, maybe consider a data share instead.
Yeah, and bi-directional as well, right? So this is great when you want to consume and enrich your own data. It's also great when you want to provide data to external organizations, whether or not they're a Snowflake customer. Someone's asking you to share data. You don't need to worry about setting up all that infrastructure, setting up all the process. You can just say, yeah, it's on the marketplace, go get it. So very, very easy to publish. And I brought this up specifically because the comment about, hey, this is going to make things, the standardization around FHIR format is going to make things a lot easier as we move to HL7. Like what that will really facilitate is if I start looking for data sets that are published specifically using, HL7 format data sets, I can start reusing queries that I'd written against my own internal tables against these third-party external shares. So not only do I not need to set up the pipeline, I don't even need to rewrite the queries based on trying to reverse engineer or trying to read through and decide, hey, what's their schema? How do I actually, write a query against those tables that they've shared? I just reuse a query that I'd previously written because I know it's valid against a HL7 source file. So
awesome, Chris. Thanks again. So I know we're over here. Hopefully this was helpful to the team.